God gave you a fingerprint that no one else has, so you can leave an imprint that no one else can. On this note, a very warm good morning and a hearty welcome to all for the third guest lecture of the expert lecture series titled Development of Latent Fingerprint Using Non-Conventional Methods. If you are a stranger to prayer, you are a stranger to the greatest source of power known to human beings. With these thoughts, we will begin this expert lecture by invoking God's blessings. I request the Christu Jayanti College Choir to lead us in a prayer song.
He formed my heart before even time began. My life was in His hands. He knows my name. He knows my every thought. He sees each tear that falls and hears me when I call. I have a Father. He calls me His own. He'll never leave me, no matter where I go. He knows my name. He knows my every thought. He sees each tear that falls and hears me when I call. He knows my name. He knows my every thought. He sees each tear that falls and hears me when I call. And hears me when I call.
Identifying latent print evidence is frequently crucial in solving a crime. The presence of friction ridges found on parts of the fingers, hands, and feet produces a latent print. These prints are composed of a variety of chemicals derived from natural secretions and contaminants. Latent prints can be found on a variety of surfaces. However, they are not always visible, and detection frequently necessitates the use of fingerprint powders, chemical reagents, or alternate light sources. Fingerprint powder is applied to the surface by brushing it on, and it works by mechanically adhering to the oil and moisture components of the latent print. The latent prints become visible when powder particles adhere to grease or moisture. In the past, the most commonly used latent print development techniques included powder dusting, ninhydrin dipping, iodine fuming, and silver nitrate soaking, among others. These traditional methods work well on a variety of surfaces. However, they are not always effective for visualizing latent prints. Furthermore, some of the chemicals used in fingerprint powders are toxic and may endanger one's health. As a result, there is a paradigm shift with research focused on development of non-conventional powders that are less toxic, easier to obtain, and less expensive. In the light of this, the goal of today's guest lecture is to provide a scientific understanding of the current state of development of latent print development using non-traditional powders as well as the strengths and limitations of their interpretation. We are delighted to welcome Dr. Richa Rohatgi as speaker for the expert lecture series. Ma'am, we deem it an honor to have you in our midst. We thank you for accepting our invitation. We welcome you, ma'am. I also take this opportunity to acknowledge the management fathers of Christa Jayanti College, Bangalore, ably led by the principal, Reverend Father Dr. Augustine George, and Vice Principal, Reverend Father Lijo P. Thomas, who have always led by example and ensured to provide a proactive and vibrant environment for students to learn. I also welcome the Dean, Faculty of Sciences, Dr. Callistus Jude, and Mr. Don Cairo, the coordinator of the Department of Forensic Science, to this session. Welcome, sirs. I also welcome the faculty members of the department and thank them for their hard work and dedication towards everyday progress in the department. Welcome, ma'ams and sirs. I also specially welcome the participants, our dear students of the Department of Forensic Science, to the session. We hope this session will enlighten you and provide you deeper insights in the field of fingerprints. Welcome all of you. Without further ado, I request Dr. Suchita Rawat, Assistant Professor, to introduce the chief guest for today's lecture.
Thank you, ma'am. Dr. Richa Rohatgi is a well-known academician and researcher. Ma'am is BSc Honours Chemistry from Delhi University and MSc Forensic Science First Division with distinction from MIT University, Noida. Ma'am earned her PhD from Department of Anthropology, University of Delhi. During her PhD studies, Ma'am was awarded UGC NET GRF in Forensic Science. Ma'am has a plethora of experience instructing at many famous academic institutions, including SGTB Khalsa College North Campus as assistant professor from 2010 to 14, MIT University Haryana Manesar Campus as assistant professor from 2017 to 2020-21, CTM IRTE in Faridabad, Haryana as assistant professor from 2021 October to 2022 November. Ma'am also has industrial experience at Truth Labs Delhi as scientific officer from 2009 to 2010, where she examined about 82 cases. At present, Ma'am is working as assistant professor in Department of Forensic Science at Lok Nayak Jayaprakash Narayan National Institute of Criminology and Forensic Science, National Forensic Science University, Delhi campus. At present, Ma'am is also guiding 3 research scholars in their PhD work. Ma'am has published 7 book chapters and 22 research papers in reputed journals. Ma'am has also written e-content for UGC, MHRD, EPG Pathshala modules. Ma'am has won Best Poster and Best Paper Award at various national and international conferences. Ma'am has been invited to give lectures in many forensic science universities and colleges across India as a resource person. Ma'am has a leading newspaper article on scope of forensic science and was also invited to talk on shows on AIR FM radio. Ma'am also served as a forensic expert on a debate panel that aired on News Nation TV. With this reputed career, we feel it an honor to have Madam in our midst to address the third talk on expert lecture series of this academic year. Now, I request you, ma'am, to please address the gathering.
Thank you so much, Dr. Suchita, and the esteemed dignitaries and the academicians. And I welcome all the students also to this lecture series. So just at the outset, I wanted to know, do I have 1 hour for the presentation? Okay. So.
Yes.
Okay. So shall I then start with the presentation?
Yes,
with
ma'am.
your due permission?
Yes, ma'am.
Okay. So these slides are visible, I suppose.
No, ma'am. I think you have to share the screen.
Okay. So please let me know if it's visible.
Yes, ma'am. You can just slideshow. You can.
Okay. So I welcome everyone for this presentation, and so fingerprints as evidence, we all know that they are conclusive evidences and they are corroborative evidences. So the two types of evidences help for the court of law to come to a verdict, whether to acquit the suspect or whether to convict the suspect. So when we talk about fingerprints, they become the irrefutable physical evidences. That means they become the conclusive evidences. So if two fingerprints, the one that we have encountered from the scene of crime, matches with the one that we have given as the suspect fingerprint, that means we can say that without a doubt, the suspect was present at the scene of crime. There could be a rare possibility that that his fingerprints have been implanted at a particular scene, but most often than not, we have the person in physical being present at the scene to have his fingerprints being present at the scene. Now, fingerprints are irrefutable physical evidences. For this reason, they become the conclusive evidences. So, if the court of law, the honorable judiciary, they find the two fingerprints being matched, that means they can say without a doubt that the person was present at the scene or that the person might have committed the crime. That is only for the jury to decide. So we as an expert or we as forensic experts, we can only say whether the fingerprints match or they do not match in our report. So fingerprints are irrefutable physical evidences found at the scene of crime. Now, at any time, if any one of you have any questions, students, you can always write in the chat box or you can unmute and ask them. Fingerprints are unique. They remain unchanged during the lifetime of an individual and they can be classified. So these are the three fundamentals of the fingerprints because of which we call it as conclusive evidences. So first is that they are unique in nature. That means no two individuals may have an exactly identical set of fingerprints unless they have been produced by the same finger of the same person. So that means they are unique in nature. So every individual having all 20 prints, 10 of their hands and 10 of their feet, will have all different fingerprints or prints in general. So rich characteristics are there which help them in becoming classifiable, and they remain unchanged means that once they are there, they have been formed during the gestation period, then in the third trimester, and they remain unchanged throughout the course of the life of a person. So until he dies, the fingerprint remains as such. It only changes with respect to his morphology, with respect to his size, and as he grows, the person grows, the fingerprints may also become enlarged. But that is, it will not change its respective position with respect to core and delta or any minutiae like those. So they remain same. For this reason, we have Aadhaar cards being made of kids under the age of 5 years, and then we have to get them again. The analysis is done again, so that the fingerprint sizes can be seen, can be matched, and that they remain unchanged. So we can have the fingerprints as classifiable. So we have Henry's and Galton's classification of 10-digit fingerprint classification, where we can classify the fingerprints as such and according to their pattern types, and we can stack them so that whenever manually we have to find out any fingerprint, like in earlier times, so we could always go and look for those fingerprints according to the Henry system of 10-digit classification. So it has various classifications like primary classification, secondary, subsecondary, then major, then second subsecondary, then key, and then the final classification. So fingerprints are unique, they remain unchanged, and they are classifiable. So which can be found impinged on any object handled with bare hands. So the advantage here for the experts or the advantage here for the law enforcement is that if a person comes at a crime scene or goes anywhere, shakes hand, touches anything deliberately or indeliberately, then there are chances of his prints being left at that particular object. So because it is by chance being left at the object, we call them as chance prints. So they may be used to link that person to the crime scene, that person to the crime scene, as well as to the evidences present there and to the victim. So to help in proving or disapproving the alibis that he says. So alibis are that the statements given by the suspect to say whether I was present at some other place at the time of the commissioning of the crime. So whether he's saying the truth or whether he's lying can be corroborated or can be supported by the presence of his fingerprints. So if the fingerprints are found, that means whatever alibi that he is giving of being present at that time at some other place is disapproved. And so conclusively acquitting the innocents or convicting the criminals. So there are different types of fingerprints. The majorly classified as visible prints, invisible prints, and plastic prints. So the visible prints are also called as the patent prints. The reason why they are called as patent prints is because they can be patented. That means let us assume a person having blood-stained hand touches a place. For example, in case of Arushi and Hemraj twin murder case, there were hand-stained fingerprints found at the terrace wall. So they are there. So unless somebody tries to deliberately wipe them, they are going to remain there as such. So they are patented there. Nobody can modify it unless deliberately done. And if somebody tries to do that also, that can also be identified. Then we have invisible prints or the latent prints. So as we were talking about in the last slide, that the prints that are formed by chance are called as the chance prints or latent prints. These are the ones that are developed, or these are the ones that are left at the crime scene by chance. So these are developed using various physical and chemical methods, while the last one are the plastic prints. Now, plastic prints are those that are found at the crime scene when the surface is impressed upon. So it has to be a softer surface where a 3D impression can be formed. While for the visible and invisible prints, they are 2D. 2D means they can be seen on a place or on an object, and they can be identified on the X and Y coordinates. While for the plastic prints or the 3D prints, they have the third dimension also to it, which is the dimension of the depth. So here, the plastic prints can be found impinged or impressed, or these are also called as impressions, fingerprint impressions. So these are found on surfaces like clay, putty, soap, greasy substances, etc. So chance prints are mostly found on any surface, be it porous, non-porous, semi-porous. And visible prints are also found on any surface, be it porous, non-porous, and semi-porous. Now, because the patent prints are easily visible, we don't need to acquire any technique specifically to capture them. So what do? We just simply photograph them. So as with the case of plastic prints, so because we can see the depth of the prints and we can see that impression of the print, so we can again photograph them, but then we only have to use the alternating light sources, or we can use oblique light sources to visualize those plastic prints, so that when we are taking an oblique light shot, the furrows and the crests and the troughs, they will form the shades. So those shades will help us in enhancing the minutiae and the ridge characteristics. What are the minutiae and ridge characteristics? We can see it here. So these are the furrows or the ridges. So ridges, between two ridges, they are furrows. And these are also called as crests and troughs. So the ridges that are the protruded are the crests, and the space between the hollow space between the two subsequent crests are the troughs. So here we have the pores, and on the ridges, we have the pores, and between these we have the ridge characteristics. Now there are a number of ridge characteristics, such as this one here is a ridge ending. Here we can see a ridge recurve. This is, by the way, an example of a loop where we have a delta here, we have a core here. This we can see there's a bifurcation here. So when we go counting from this side to this side and we see one ridge bifurcating into two, we call it as ridge bifurcation. When we go from the other side and we see two ridges coming together, we call it as convergence. Then here we can see a small island also. So there are different ridge characteristics. Now, because as we see that the plastic prints and the patent prints, or what we call it as visible prints, are visible to the naked eyes or the unaided eyes, we need not have to have any particular development technique to visualize them. We can easily visualize them and we can take the photographs for the comparison purpose later on. But the most important ones are the latent prints. These are the tricky ones. These are mostly found at the crime scene because sometimes the culprit also may not see them. So the prints are just left like that. So if it is a plastic print or a patent print, the perpetrator may also see it. So he would try all the means to wipe it off before leaving the crime scene. But as with the case of latent prints, they are invisible. So sometimes inadvertently or accidentally, he just leaves behind his latents behind. So these are the ones that we have to detect, and these are the prints that we have to tap upon to identify the person. So latent prints means hidden, invisible to the unaided eyes. These can be detected with the help of physical or chemical methods designed to enhance the latent print residue. Fingerprints are deposited by naturally secreted material such as sweat, sebum, lipids, foreign materials picked up on the hand. Now, the fingerprint residue is 99% of water, and it is only 0.1% or 1% that is different organic and inorganic substrates that we have to tap upon. So now these are some of the conventional methods that have been in use for now many years to identify these latent prints, some of which Ms. Devi has already elaborated on. So there are other techniques also which have come up over the years to identify these latent prints, and they have come up only because the conventional or the ones that we have been using had some disadvantages or had some demerits which had to be overcome by the currently or more specifically the latest or modern techniques have tried to overcome. So some of the conventional methods of developing the latent fingerprints. So as we discussed that they can be classified as into physical and chemical. So let us first consider the physical methods. So the first amongst them is the powder method. Now we can have different types of powders with respect to their composition, with respect to their color, and with respect to their properties. So we have black powder. This has mostly graphite or charcoal black. Then we have white powder, we have gray powder, which has alumina, we have silver powders. So these are the different types of powders that we can use. And initially, when we start to reach the scene of crime to develop the a particular case of fingerprints, of latent fingerprints, we try to develop them using the powder methods only. Then comes the magnetic powders. Now, magnetic powders had an edge over the conventionally used powders, that the formulations containing ferric oxide, rosin, and manganese dioxide, etc. So the advantage of magnetic powder over the normal conventional powder like black powder, etc., was that the magnetic powder could adhere on a surface which is horizontal. Like for example, this is in a case of burglary. If I'm suspecting the fingerprints of the burglar to be on the safe or on the almirah lock, now in that case, if I'm going to use the conventional powder, it is going to get deposited a little on the surface, while maximum of it will go wasted while dusted. While in the case of magnetic powder, it gets adhered on the vertical surfaces also. So this way, there's the economic. It is more economic in terms of the wastage. So also it gives better results. So there are certain substances or certain objects where we have to look for which one has to be used. So then we have the organic powders. So in organic powder, also in magnetic powder, whatever is the remnant, whatever is left behind, we can again, it's like a piston brush, the picture that we can see here. So it's like a piston brush. So we can pull the piston from here. So all the magnetic powder gets adhered here at the muzzle end, and then we can just drop it off, leave the piston so that it comes off on the surface. So wherever there is the sweat, that it gets adhered to that, and wherever there's no sweat or no fingerprint, the it will not adhere to that. So whatever is remaining, we can put it back. Then comes the organic powders. They were used when people realized the long-term use of the toxic inorganic powders, which contain the lead, mercury, cadmium, copper, bismuth, would cause the health hazards. So these were based on the cornstarch mixed with the potassium bromide. So this was mixed with that, and then it was pulverized, it was dried, and then it was used. Then came the luminescent or fluorescent or phosphorescent powders. So many of such types of powders contain natural or synthetic compounds that fluoresce or phosphorus upon exposure to the UV light, laser light, or other light sources. So there are many dyes. They can be organic or inorganic synthetic dyes that we have, which can be used or utilized as the luminescent powders. So we have nanoprobes for that, and we can mix it with the conventional powders to spray it or to just sprinkle it on the residue surface, and it will get adhered to the print area, and wherever the print is not there, we can again visualize the print. So it is going to give the contrast. Wherever the print is not there, it is not going to get adhered. So we'll just dust it off, and we can visualize the print clearly. Then we have the thermoplastic powders. This was also anciently used. So this used a photocopier toners or dry inks were used to develop the latent fingerprints. And upon exposure to heat, the latent fingerprints become fused to the surface. Then came the small particle reagent. Small particle reagent, or SPR, traditionally consisted of a suspension of fine molybdenum disulfide particles in detergent solution. So we have to make a suspension of the SPR reagent. The particles adhere to the fatty constituents of the latent fingerprints, and they form a gray molybdenum disulfide deposit. Now, over a period of time, this SPR, molybdenum disulfide, was then removed, and it was replaced with zinc carbonate, zinc oxides, barium carbonates, and barium sulfates. So these were used along with different dyes for dye formulations to make it more pronounced, more enhanced, and more pronounced fingerprints. So these are examples of the ones that we just discussed in the previous slide. This is the first picture, shows the black powder developed image. Then we have a fluorescent powder image with development with two different fluorescent dyes. Then we have a thermal powder developed image. We have white powder, then we have magnetic powder. And this is a small representation of how it is done. So here we have the fingerprints, and this is how we will put it. And this is what we can put it back. Then the chemical conventional methods of fingerprints that have been in use for a long time now are iodine fuming, where the iodine vapors are absorbed by the fingerprint secretion to give a yellowish brown latent prints fixed with starch solution. Then we have, because iodine fuming method, it is it gives the prints visible temporarily. So we have to either take a photograph of it, or we can fix it with the starch solution. Then comes cyanoacrylate fuming, which is also called as superglue fuming. Here, the latent fingerprints are exposed to superglue or alkyl to cyanoacrylate ester to form the whitish fingerprints. Now, further enhancement with dyes such as rhodamine 6G, or basic yellow 40, or basic red 28, gentian violet, or DMA-AC, which is dimethyl aminocinnamaldehyde, and diketonic chelates of the European rare earth metals for better visualization. These can be added. Then we have ninhydrin, and ninhydrin again has many derivatives also, like 5-MTN and DFO, etc. So ninhydrin method may be applied by spraying, swabbing, or dipping post processing treatment by applying heat to accelerate the reaction. So here in this picture, we can see that the fingerprints were there. It had been sprayed with the anhydrine solution, and then heat was applied. So heat can be applied using a hot iron, or it can be kept on a hot plate, or it can be kept in oven for a while, and then we can visualize the prints, which are of rumen purple color. So this is the positive for the anhydrine. So basically the anhydrine reacts with the amino acids that are present in the sweat. Then comes the 5-MTN, 5-methyl thionanhydrin, another variant of the anhydrin that develops the purple red colored prints. Then comes the DFO, which is 1,8-diazofluorotronine. DFO is an anhydrine analog, which may be used on porous surfaces and may be viewed under the ALS, that is alternating light sources. It is used before anhydrine is considered more sensitive. Then we have another derivative of anhydrine, which is 1,2-indendione, and is extremely sensitive. Is extremely sensitive amino acid reagent, which develops the latent fingerprints similar to DFO developed prints. And this may further be enhanced with zinc chloride treatment. Then we have some pictures here of cyanoacrylate, indendione, DFO, anhydrine, iodine fuming, and 5-MTN. This is in continuation to the conventional chemical methods, which is next is silver nitrate. This again is used traditionally where we have the fingerprints, and again, these are all for latent fingerprints. So development techniques are only used for the latent fingerprints. So here again, we have to react it with the silver nitrate reagent, and the silver nitrate. So silver nitrate reacts with the sodium chloride that is present in the residue, sweat residue, and it rapidly turns black on exposure in the sunlight. So the demerit or the drawback of this test is that it requires sunlight for the reaction completion. So again, it cannot be used in conditions where very cold regions, polar regions, and glacier regions. So we cannot use this method. So which method should we use then? So we can use any of the other methods like Potter methods, etc. In cases where we have blood-stained fingerprints, which method should we use? So we can use amidoglar. So to enhance the blood-stained fingerprints, we can use impressions which are both with amido black, which are both on porous as well as non-porous surfaces. Now you may also think that if it is blood-stained print, it becomes visible. Why do we need to firstly consider it under latent prints and then developing it? So blood-stained prints are those basically in this case where a small amount of blood is there. So it is not a completely blood-stained print, or it is not completely like we see, say, supposing if we have seen the wills or pronotes where we have to put the, or stamp papers where we have to put the thumb impression. So we put a groomed inked thumb impression. So similarly, we have a groomed blood impression, blood print, then we can only visualize it and photograph it, considering them as a patent print. But in case we have faintly red colored print, which we know is a latent print because the most of the print looks is invisible, so it is not clear, but portion of it has blood adhered to it. But I don't want to use any method which is like say supposing powder method, which is going to get adhered with the blood. It is not going to enhance my ridges. So in such cases, I can use the amido black. So amido black reacts with that hemoglobin, and it is going to give a black impression more pronounced. So the ridges are not going to get damaged with that. So dark black again can be used to develop the dark blue or black prints on greasy or waxy non-porous surfaces such as glass, metal, milk, cartons, interior of gloves and candles, etc. Then we have osmium tetroxide. This is again used in similar way as that of iodine fuming. So in iodine fuming or super glue method like cyanoacrylate or in osmium tetroxide, what we have to do is we have a small jar. or a glass chamber. It's a closed glass chamber. We have a lid on top of it, and whatever substrate, say supposing a check leaf, or maybe a suicide note, or maybe an anonymous letter, or maybe whatever substrate that I'm expecting to find a print on that, I'm going to put inside that. So I can either hang it on the top of the lid, or I can just put it closely near one of the edge of the chamber, glass chamber. So like how we put the TLC sheets or TLC plates inside the glass chamber, similarly we put the samples also. Now we have the in case of iodine fuming, we have iodine crystals. So iodine crystals are brown in color. So we have them, and we just either just let that be, or we induce some heat from beneath so that there are fumes. So the fumes come up and they get adhered onto the fatty or the greasy substances, greasy residue in the fingerprints, and the fingerprints become visible, and that is when we take the photograph of it. In case of cyanoacrylate glue fuming, we have the same prints developed, but this time instead of brownish or yellowish prints in case of iodine fuming, we get wheatish or whitish or creamish shade prints in case of cyanoacrylate glue fuming. So if I have a substrate white in color, I may not use cyanoacrylate method because I may not be able to decipher where the prints are. So that can be used in contrast. If I have a lighter colored substance, I can use iodine fuming. If I have a darker colored substance, I can use super glue method. So we see that the reason why these different powders or different methods, chemical and physical, uh, have been used because one or the other method have some or the other demerits to it. Like for example, silver nitrate, it depends upon sunlight for the reaction completion. So without that photon, this cannot be, the reaction does not get completed. In case of ninhydrin, we have to introduce heat so as to visualize the plots. Similarly, so to overcome the drawbacks of each of the previous method, we had come up, or the scientists had come up with the latest method. Then we had the physical developer method. So this was generally applied after DFO and anhydride methods. Because why? Because physical developer method is it's a destructive method. So if we use this prior to ninhydrin, then the prints are not left for ninhydrin. So it is best suited for developing prints on paper bags, paper currency. Sodium hypochlorite solution is sometimes in conjunction with the physical developer used to darken the stain or lighten the background. So it gives that contrast to it. And then we have VMD, which is also called as vacuum metal deposition method. So this is used on semi-porous and non-porous surfaces. So sometimes some methods may not be used on certain types of substrates. So we have to look for different things. Some may be used in tropical regions. Some may be used in dry conditions. Some may be used in wet conditions. Like for example, SPR can be used in wet condition. For some may be used on porous surfaces, some are good for non-porous surfaces. So we have plethora of such things, such array of such substrates, and similarly we require different methods. But then the experts had come up with so many different types of methods. But then the IOs, the police officers, they came in a fix that at the scene of crime, they cannot think of which method to be applied. Say, for example, this is a picture of SPR. So this is taken on wet surfaces. This is a picture of vacuum metal deposition where gold particles, nanoparticles are deposited there. This is a picture with silver nitrate. This is a Medo black, Sudan black. So they were in a fix which one to be used when, and they don't have that much of time at the crime scene to establish which method is best suited for that particular crime scene or that particular fingerprint. They pose that they had those problems, and they pose their questions, their queries, their problems to the researchers, to the forensic experts. And then came the idea that the conventional powders are now not helping the IOs as much as we were expecting it to help them. So the scientists had come up with some non-conventional methods. So before coming to that non-conventional method, there are certain few more chemical methods that are in use that I just want to name. So Next is PTC, which is phase transfer catalyst. Now, phase transfer catalyst can be used on sticky side surfaces. Like, for example, the suicide bombers, they fix the bombs, or they adhere the bombs to their bodies with the special type of tapes. And when they are putting those tapes, they have their fingerprints coming onto that. But there is no specific method known till now which can be used to develop the latent prints that are found on the sticky side of the tapes. So that is when the PTC, or the phase transfer catalyst, came into picture. Then there's also densyl chloride that gives the black impression on both porous and non-porous surfaces, again used for the blood stain prints. Then we have liquid drops, which is also applied after DFO and anhydride, just like we use the previous method, which was the physical developer method. Then we have oil red and Nile red. These are again dyes, luminescent dyes that we can use to develop the fingerprints. Now, in case where super glue gives whitish color, but I cannot use iodine fuming at that surface, but I want to visualize the print. So I can introduce oil red or Nile red along with the super glue, that is cyanoacrylate, so as to make the image sharper and in contrast to the background, so that I can visualize it better. Then we have Fleming's reagent. So it is a mixture of osmium acid, chromic acid, and glacial acetic acid to develop the latent fingerprints. The vapors of Fleming reagents penetrate the fatty acids of sweat. The metallic salts are reduced to metals, and substrate is then soaked in diazine fast yellow dye, which fluoresces under the UV light. The background appears bright yellow, while the prints developed are black in color. So those were some of the conventional techniques. Now, very quickly, let us come to the non-conventional powders. So initially, most of the time it is seen that the conventional fingerprint powders are toxic, or they pose potential health hazards, or during a long course of time, the experts may also be developing some chronic problems due to that, because most of them contain either lead, cadmium, bismuth, any of those hard metals. So in order to overcome this disadvantage, use of some common household kitchen powders came into being, which are non-toxic, less expensive, and they're readily available also. So for instance, turmeric powder, cocoa powder, custard powder, corn flour, baking powder, and henna powder, flour or leaves extracts, vermilion, wax, soil, etc. They all have come into picture for development of latent fingerprints. So this is a picture developed with turmeric on currency note. This is with vermilion on a tile. The picture is not too clear for the prints to be visualized, but a palm print can be visualized. Then, so those were some of the non-conventional household methods, but then there are also some modern techniques. So they are non-conventional modern techniques which do not require any harmful chemical. So which are like laser beam with the argon light. So light amplified stimulated emissions of radiation beam is used for developing the crime scene prints at odd surfaces. Odd surfaces are those which are not the regular surfaces that we come across. So odd surfaces could be the fruit peel. So a perpetrator has just bite an apple and just left that half-bitten apple at the crime scene. So we have to collect that. It could be the Rexine bag just put back from one place to another. So the prints become prints come there. So we have to develop those. It could be surfaces like the underneath of the tables or the chairs. So there we can have such prints, or we can have that in snow. Say supposing it's a crime scene at higher altitudes. So there we have it at snow. So if the snow melts, the prints are also gone. So we have different types of methods that we can use to visualize them. Also, very old prints can be developed, and also chance prints, which otherwise are difficult to develop. Chance prints are left at the crime scene by chance. So we do not know whether the person would have touched this, would touch this. So there should be a method to identify the location, where exactly in the entire room to look for that print, so that we can pinpoint a particular location, and then we can use any of the methods that we have listed so far. So at a bigger crime scene, it becomes very difficult. So we can use these light sources to just pinpoint those locations, and then we can visualize, enhance them, critically examine them. Then we have polylights. So it is a portable light to carry to the crime scene, or maybe used in mobile vans for the on-spot detection. And it comes with different filters of various wavelengths. So we know that a print is there. So we can, with hit and trial, we can see which filter gives the maximum visualization or maximum contrast for that particular surface type. Then we have polyray. It is the latest equipment being used for the latent fingerprint detection. It is both battery as well as electricity operated with pistol grip, lightweight and very handy. We have also OmniPrint 1000, which is a light kit, and it is portable with high intensity source of light. The laser has different intensities of light and works well with fluorescent powders. Dusting lighting kit. So the dust lighting kit, this is an equipment that is specifically designed and proved to be a boon for lifting chance prints from dusty surface. Say supposing there's a dust adhered on this surface because the room was locked for a long period of time, many years. This room was not opened and cleaned. So there's dust, a layer of dust all over the furniture and everywhere. Now, if some person tries to make an entry into that room and accidentally just touches a place, then the fingerprints become, they come there and they become visible also. But at the same time, it cannot be classified under the patent on the plastic. They are the latent prints because the prints have been put on the surface with the naked hands. So that is why only the sweat pores have put the fingerprint residue or the sweat residue onto the surface, making these visible, these ridges, impressions come onto the surface. So we have to have some technique to develop them. So we can use the dust lighting kit. So without any destruction to the surrounding dust or without any destruction of putting extra pressure onto the expert to visualize the print that has been there, because the dust has been lifted from that place and the prints have come there. So it is a lookout principle of exchange. So we have to use a method which is non-destructive. So the dust lighting kit comes handy there, which is based on the electromagnetic polyvinyl sheet. We keep it on that, and with those electrodes, the charged electrodes, as soon as we switch it on, there's the complete circuit of the flow of electrons, and it gets the entire negative image onto the polyvinyl sheet. So we can see the same can be used for the lifting of the shoe prints from the clear surface, from the 2D surfaces. Then we have AFIS, Automated Fingerprint Identification System, also called as Biometric Identification. And now we know that India has the largest AFIS database in the world. Then comes the principle around background-free latent fingerprint imaging. So this is the difference in the optical properties between contrast agents and the background. So the entire list of these methods is based on single property, that there are different metals and they absorb different light of different wavelength of light, and the electrons get excited, they reach the higher ground state levels, they become excited and they want to come down to their ground states, so they release the energy and they come down. So once they release the energy, those photons or those the emission of that light is can be captured onto the different surfaces. Like we can have the absorption spectra, we can have the transmittance spectra, we can have the UV spectra, like that. So depending what wavelength of light has been absorbed and what is emitted, on the basis of that we can identify this. So the optical properties of each can be visualized there. Now different excitation wavelengths, so that is why sometimes we can use the different light source of different wavelengths, the filters. Sometimes we can use the different combinations also, and to visualize that. So we can understand this better when we see an example of VSC, that is the visual spectral comparator for the document examination. So their combination of lights, so that is also a play of light. So sometimes if I spray my document with any of my previous fluorescent dyes and I put it in the VSC also, not just for the ink analysis or the different ink forgery, I can also detect fingerprints in that. So different emission wavelengths, different luminescence lifetime, different plasmonic properties and photothermal properties and electrochemiluminescence properties can help us in identifying the fingerprints. So even if at a bigger crime scene, and I do not know what places to look for the smallest, tiniest of partial print also, I can make use of these light sources to identify them. So these are the pictures of polylight, laser, polyray, electrostatic lifter, and alternating light sources. So we can remove the portions ahead, and we can keep changing the different light sources. So this is at 495 nanometers. We have series of such different light sources of different nanometers to visualize those prints. So we can see where the print is, we can locate it, and then we can use any method to visualize and develop them. Then we have AFIS. So AFIS is fingerprint technology that has come a long way since its inception, more than 100 years ago. I think we all know about the Unique Identification Authority of India, UIDAI, that was created with an objective to issue Aadhaar card to all residents of India to eliminate the duplicacy and fake identities. So this is based on the fundamental principle of fingerprint that says that all individuals have unique fingerprints, or no two individuals can have an exactly same set of fingerprints unless they have been produced by the same figure of the same person. So just like fingerprints, we have iris scan, we have other biometric features also that are equally rare and unique to each individual. So this is a small diagrammatic representation of how the automated fingerprint identification system works. So these are the flow chart or the minutiae extraction. So this goes on the 0 and 1 binary form. So we have to first demonstrate the system that these are the bifurcations, these are the codes, the deltas, and these are the minutiae or regions that it has to look for. So it is going to look for those details in the individual's fingerprints at that particular location with respect to core and delta and with respect to the intra-spacing of those minutiae to identify whether it has been impressed by the same person or not. Then there are some recent advances in the fingerprints. So an overview to that is that the recent progress on fingerprint visualization and analysis has been done by imaging rich residue and utilization of such nanoparticles and nanophosphors in fingerprint detection using sensors and different light sources. Also, by extracting presence of human metabolites of medical and diagnostic values. For example, two-person having shake hands with each other, then we can use the touch DNA to identify whether the person was physically present at the scene of crime or whether the person has touched the other person or not. And these researchers, trust me, are record breakers, or they are the most sought for in cases of sexual assault cases. So these can be tapped upon more progressively. Then we also have by detection of specific chemicals being present in the latent physical fingerprint residue, with an emphasis on the utilization of the mass spectroscopy or IR spectroscopy, Raman and micro X-ray fluorescence spectroscopy as means of rapid and non-destructive imaging. Then fingerprints from metal objects, even when they have been wiped or washed off. So as we know that if we have a bucket of water of 20 liters and we have, say, few drops of blood in it, and we draw a sample out of it and we do a benzodine's test, it's going to be positive for it. Although we cannot see the blood traces there, the water will still be naturally transparent, but the presence of blood can be identified. Similarly, we can have the fingerprints detection also, even if they have been wiped off. So in cases where people have tried to dump the body, taking it in a car and then cleaning the car, washing away the surface, the top surface, changing the upholstery and everything, still we can find out the fingerprints. So in recent study, researchers have found that chemical deposits that form the fingerprints have electrical insulating characteristics, which can block the electric current, even if the fingerprint material is very thin. So only a few nanometers thick. So we can use the thin film mechanism for identification of those. By using electric currents to deposit a colored electroactive film, which shows up in the bare regions, that is furrows, between the fingerprint deposits, and it gets the researchers can create a negative image of the print, in which what is known as an electrochromic image. So according to the team of forensic scientists, this method is so sensitive that it can even detect fingerprints from metal objects, even if they have been wiped off or even washed off with soapy water. Then there are fluorescent films enhanced by adding fluorophores molecules, which are electrochromic and which gives fluorescence in UV light, provided a third color can be adjusted to develop a high contrast fingerprint image. And this gives scientists an extra tool in developing contrasting colors for the latent fingerprints. Then we have micro X-ray fluorescence, which we also call it as MXRF, that detects the sodium, potassium, chlorine elements that are present, basically mostly the electrolytes, as well as many other elements that are present in the fingerprint sweat composition. The elements are detected as a function of their location on the surface, making it possible to see the fingerprint where the soils have been deposited on any surface. So this method is useful in cases where the prints are age-old also, not just for the recent ones. Then we have non-invasive procedures also. This technique has several advantages over the conventional fingerprint detection that involves treating the suspect area with the powders, liquids, or vapors in order to add color to the fingerprint so that it can be easily seen and photographed. Since using traditional fingerprint contrast enhancements means the powder compositions, like we use the thermal powder, organic powders, those. So it is sometimes difficult to detect the fingerprint present on certain substances, such as multicolored surfaces. So for those, we use the fluorescent powders of fibrous papers, textile, wood, leather, plastic, adhesives, and human skins. So we use this non-invasive procedure. So it is mostly based on the laser prints. So most immunological examinations require blood samples, which is an invasive method. This technique eliminates that problem, and fingerprint or sweat deposits are left pristine, like on a cigarette butt or on a glass, if somebody has sipped from that glass, so like this. Although these techniques that now we are talking of are at their very elementary stage of research, so their use at the crime scene cases has not yet been studied so far. They are in the preliminary stages of researches. A lot of research needs to go behind before they come in the market for the normal use for the use and the law enforcement. Then we have the time of flight secondary iron mass spectroscopy. So this has been introduced in the forensic field to link the TUF finger marks to the evidence found at the scene of crime, such as reliable age prediction of the latent fingerprints. Then we have immunolabeling methods for the chemical imaging of the human finger marks with the nanoparticles functionalized with antibodies. This basically to say whether a person has a certain type of disease or not. So the sweat residue is tapped upon. So like a simple preparation of antibody functionalized gold nanoparticles through the use of antibody magnetic particle conjugates, various drugs or drug metabolites, such as those of delta 9 THC, tetrahydrocannabinol, methadone, narcotine, could be readily detected in the latent fingerprints. Then we have aptometer-based methods where the affinity and specificity shown by the aptometer target binding complexes have been found to be higher than those of the antibody antigen complexes. So the use of this technique for the detection and visualization of the latent fingerprints using lysozyme specific aptometer-based reagents can be done. So this is an example of the same, a charged latent fingerprint on a PVDF substrate developed by using the aptometer-based reagents. So we can see this is the picture how it looks like, and this is on zooming in further. We can visualize each minutiae and the rich detail, even the poroscopy and the third level identification of the fingerprints is also possible. Then we have nanoplasmonic methods to visualize the latent fingerprints, which use the gold nanoparticles or silver nanoparticles on the aptometer-based uh, complexes. Then we have a recap of all the other methods that I have just mentioned here. So it is an obvious question that where do we go from here? That we have come so far in the fingerprint development technique also. We can go further. There are small researches at different research labs all over the world have been taking place, and few papers have been published. So I have just cumulatively put them together here, which is some of which are dealing with the anti-Stokes powder or powder suspensions, which are either based on phase transfer catalyst or on the SPR based compositions. Then there are modified fuming methods, which are basically based on the fundamental principle of the cyanoacrylate method and its different variants. Then we have nanoparticles and nanofluorescent suspensions. We also are working on quantum dots. I have recently published one book chapter in D. Croutier's publication that is based on the nanophosphorus development of latent fingerprints and its applications. So we have non-stoichiometric reagents also that are working on the development of prints, which are faint, which are partial, which are a little smushed, and which have blood fluid prints composition into it. Then we are also working on the chemical imaging, which has residues, explosive residues or drug residues. And then there are also scientists are working on the bacterial profile and the possibility of identifying any disease or illness so far. There are also researchers on done recently on the peels of different fruits and vegetables and drying it, mixing it, and then making a powder of it, and then developing the old and new prints out of it. There are also researchers that are working on fingerprint formulations which are on wet surfaces, on surfaces which are exposed to very high heat. For example, case of a bullet or a cartridge. So when you fill the shotgun and you fill the bullet or you load the bullet yourself, so the cartridge cases most possibly you have the fingerprints of the person putting those cartridge cases or loading the bullets into the firearm. So then after firing, the cartridge case just ejects out at the crime scene itself. So if we collect those cartridge cases and we try to collect the fingerprint, are we able to collect it or not? Because when the firing pin strikes the anvil, the temperature inside the barrel goes to as high as 2000 to 3000 degrees Celsius. So do the fingerprint remain there for us to visualize? So even at higher temperatures, even if it is, say somebody has used that firearm to kill someone and then thrown it in the running stream of water, maybe in a lake, maybe in a pond, maybe in a river, and the police confiscate it or they recover the firearm. Are they still able to identify the fingerprints from that wet surface, or they just go washed away? So these are the things, or these are the areas where the researchers are now bound to happen. So the conclusion for this research, for this presentation is that forensic researchers are continually aiming to develop novel methods for obtaining the personal identification through fingerprints. Accurate fingerprint identification is of great importance in providing information about a fingerprints, donors' age, race, sex, blood group, dietary habits, drug abuse, medical history, etc. So on the basis of the fingerprint or dermatallographics, we can also identify the different ethnic groups. So there are researchers where they have come up with samples as high as 10,000, 20,000 samples they have worked on, and they have published papers to say whether the ethnicity can be established or not, whether the race can be established or not. Then many anthropometric analysis and database studies on the ridge density analysis, on the palm density, on the hand dimensions, the finger dimensions, the digit ratios, all these are also being studied, and there are researchers to prove that these dimensions of the anthropology, along with the forensic fingerprints, give very vital information as to the personal identification of an unknown person. Some researchers have also studied fingerprint relation with respect to criminal behavior, delinquency, and psychological theories of crime. And in future, methods are reliable, portable, fast, low cost, sensitive, selective, and non-destructive are going to be highly needed for visualizing the latent fingerprint marks physically and for imaging them chemically. So we have different methods that we are aiming at. And these are the methods. If you students also come up with your projects, with your little dissertations, you collect samples, you try and mix different compositions, come up with a composition, try to develop prints with it, see if the prints are getting visualized, put them under the microscope, see them under the fluorescence, see them in different wavelengths of IR, UV, all those combinations. See if you can come up with something, then nothing like it. So if all these researchers can, you all can also do wonders in this. So with this, I end my presentation. I hope I have not taken too much of time. We started at 11:30, we are ending at 12:30. Oh, sorry, 11:15, we are ending at 12:15. That's all from my side. I'm open to questions. Thank you.
Thank you, ma'am, for the engaging and profound session. If the students have any questions, they can unmute and ask the questions one by one.
Dr. Richa, I have a question. I have
Yes,
kept
please.
3 questions for you, if you could answer them. With regard to the legal admissibility, is there any work that has been done on the legal admissibility of non-conventional household powders? Because they are the
Okay.
one that we can use at crime scene. So
Right. So the legality part or the legal admissibility of the non-conventional has not yet been discussed so far, because researchers are still in the quest of coming up with many such samples. Because most of all, we encounter the partial prints, smudged prints. We encounter prints at the crime scene which are chance prints, left by chance. So they are not groomed prints, the ones that we actually work on in the laboratory as researchers. So the quality of prints are very low at the crime scene. So at that time we have to the challenge for the prosecution and for the jury is that to fix that particular fingerprint to the culprit, to the suspect that is there standing. They cannot rely on the non-conventional technique for that matter. So they have to rely only on the ones that have been in use for a long time now, and they refer to the cases also. But here at NICFS, NFSU campus, we have training sessions for the judiciary, for the SPs, for the ranks of DSPs, and for the senior public prosecutors, from scientific officers, from the CFSLs and FSLs all over India. So they come and they tell us their challenges, they tell us their quests, they tell us what are the shortcomings that are there. Most of the judges are not from the scientific background, that we have to understand. So for them to tell them about DNA, to tell them about APHIS, to tell them about these nanophosphors or quantum dots that we are using now is not going to serve the purpose for their delivering justice. So for now, the legal admissibility of these non-conventional is far, even to say the least. They are only relying on the powder methods, most of the times even the chemical methods, and that also when the IO is well versed. In most cases we have also seen, like in my days of as in the lab as scientific officer, and now that I'm working in the training, I have seen that the IOs are sometimes, even if they are well versed with the techniques, they are not well equipped. So the chemicals or the different methods that we tell them that they can use, those are not given to them for developing the prints at the scene of crime. Sometimes they don't understand which chemical of which powder is to be required to collect the print from the crime scene. So a very important print, let me quote a case here of this twin murder case of Arushi and Hemraj. For consecutive 2 days, the police, the Noida police, not to say anything, but everybody knows about this case. They did not know that Hemraj has also been murdered, and they were suspecting Hemraj to be the killer of Arushi. Only after 2 days that they got to know, when they reached the terrace door, they it was locked, and they tried opening it, and they saw a bloodstained print there. They had only taken a photograph, and that too a mid-range shot. They did not take the close-up shot of it. Sometimes the IO does not know where to collect the pictures. So they were taking the pictures on a concrete wall. There are abrasions in the wall. So barely taking a photograph of that patent print does not help the expert at the lab to compare. So for that reason, in such cases, it is advisable to call the experts at the scene of crime. They are well versed with it. They are well equipped also. So these are the certain things, because it is like the judiciary, the police, and the forensic people. These are the three pillars of the law enforcement. So they have to come hand in hand. They have to work in cohesiveness for the criminal justice system. So the legal admissibility of the non-conventional, I am not seeing it also for like in the near future also to come off. But uh, in the research field, there's a lot that has been happening. That is a lot that has happened, and that is a lot more that is still to be tapped upon and to be done.
Now my other question is, for overlap prints, what could be the best method, both in terms of non-conventional as well as conventional method, for extracting the latent print? Overlap prints.
Yes. Yes. So in case of overlap prints, I would suggest to go for AFIS. AFIS is a software where we can first take it for one of the print. So we have to align it. See, the students can understand it like this. Say, supposing this is your biometric sensor where you have to put your thumb impression. Now, if this is your thumb impression, which is already in the database, what does the AFIS do, or what does the biometric system does? So when you're putting your thumb impression again, it is going to look for this impression in the database, and it is going to look for this and come up with the possible matches. Sometimes it will take a longer time. You have seen when you are putting it, it takes a little longer than usual. It may be because that the print is not aligned like this. It may be aligned like this. Sometimes it will say that record it, you have to retake it. So because the alignment was done. In lighter deviation of the alignment, it will do it itself. But in large times, it may not be able to. So it will say record again. So no record found will come. So you have to do it again, and you will think my record is already there in the database. Why is it not taking it? So when we have such type of multiple superimposition of the fingerprints, even if they are superimposed aligned from one to another, we can make use of AFIS. AFIS is particularly going to take one specific, and it is going to locate for the minutiae that are respective to that, and it is going to give you a print separately, segregating it with the another one. So when we are taking another one, we can segregate, and we can visualize the two and compare if the first level of identification with respect to pattern type, then second level of identification with respect to minutiae, or the third level of identification with respect to the pores also can be done.
Thank you so much for that.
Thank you, ma'am, for patiently answering our questions. Gratitude is a powerful catalyst for happiness. It is a spark that lights a fire of joy in your soul. With these thoughts in mind, I invite Ms. Aishwarya Shashikumar, Assistant Professor, Department of Forensic Science, to deliver the vote of thanks.
Thank you, ma'am. Power comes not from knowledge kept, but from knowledge shared. On this note, we sincerely thank Dr. Richa Rohatgi for taking time out of a busy schedule and delivering an online lecture. It is a great honor for our college to have welcomed such a distinguished speaker who has made significant contributions in the field of forensic science. It was a pleasure to listen to you speak, ma'am. It was clear that your presentation captivated everyone in attendance. Ma'am, I'm confident that your exhaustively covered lecture insights will be extremely beneficial to our students. Best wishes for good health and success in all your future endeavors. This session would not be possible without the support and guidance of the members of the management led by the Principal Reverend Dr. Augustine George and Vice Principal Reverend Father Lijo P. Thomas. Thank you, Fathers. I extend my gratitude to Dr. Callistus Jude, Dean, Faculty of Sciences, and Mr. Don Cairo, Coordinator, Department of Forensic Science, Christo Jayanti College, for encouraging us to strive better and helping us in conducting such programs. Thank you, sir. The smooth conduct of the guest lecture is because of the faculty members of the Department of Forensic Science. I thank all the dear teachers for coordinating the program to make it a success, and a special thanks to Dr. Suchita Rawat for arranging this session for the department. Thank you. I also thank all the students of BSc and MSc Forensic Science for being a great audience, for their patient listening and asking their doubts to make the session interactive. Thank you, dear students. I would like to extend my thanks to the IT department of Christo Jayanti College for providing the necessary resources to conduct this event and ensuring there was no glitch all through the session. Thank you, sirs. Thank you, one and all. As we have come to the end of the program, I request all to join together for the college anthem.
Like a golden disc, swung in the rising east, lights up a life divine, fills knowledge in our minds. Laurels and the book make us sublime. With the mighty Lord, we soar high on the bedrock of faith. Integrity of force, human dignity true, excellence we strive. Christu Jayanti light and prosperity. Christu Jayanti light and prosperity. Raise the joy and peace, sprawl our hearts and minds. On we march our goals as a beacon for the world, with a passion for our growth and a love for humankind, united and strong in excellence on the bedrock of faith. Integrity of force, human dignity true, excellence we strive. Christu Jayanti light and prosperity. Christu Jayanti light and prosperity.
I request all the participants to turn on their videos for a photo screenshot of the session. A feedback link will be sent to your WhatsApp groups. Student participants can fill the feedback form. I request all of you to fill the form without fail. Thank you all.
Thank you, Dr. Richa, once again. It was a very nice session. Thank you very
Thank
much.
you, sir, for having me. Thank you, Dr. Suchita. Thank you all.
Thank you. Thank you. Request the host to end the meeting.